Okay, here's our video for Monday. Today's Sunday, October 4th. Okay, this is a change of base formula that we don't really need to use anymore, but they've got it in the lesson. I want you to know how to do it, and then you can use your calculator as needed. If I want to convert log base 5 of 28, this is the exponent that 5 is raised to 28. We know 5 squared is 25, so it's a little more than 2. We convert it into log base 10. Let's pretend it's flashback in time that our calculator only works in either common log or natural log. So you take the log of what you're of 28, what you're right here of x, log of 28, and then divide it by the log base 10 of this base, log of the base you're converting from. Okay, so notice I've got base 5 and taking the log of 28 base 5, so I'm converting from base 5 to 10. Log base 28 divided by log base 5. In natural log, converting to natural log would be log of 28 divided by natural log of 5. Here's another example to hit home. I want to go from base 3 to either base 10 or natural. So again, it's log of 30 divided by log of the old base 3. Natural log of 30 divided by the natural log of the old base 3, okay? And that'll get you your answer of what 3 is raised to get 30. And again, 3 cubed is 27, so it's 3 point something. Exponential rules, and when we multiply like bases, you add the exponents. B to the m times b to the n equals b to the m plus n. As far as logarithms, log base b of m times n, remember these are base b, and I'm taking basically log of this times this. Basically, what are we going to do? These represents the exponents as b is raised to get m and n. So notice I can rewrite the log of base b of these factors as individual logs of each factor added together. Okay. So notice I'll take the log of base b of m plus the log of base b of n. Okay. So again, because what do you do when you multiply like bases? You add the exponents, and that's what we're doing. We're adding the exponents, okay? So when you have a single log and we're multiplying, those factors can be taken out, and you take the single log of each factor and add them. So when you see this is expanded form. And I see this, I can rewrite it as, here's these factors as a single log, okay? All right, exponentials, common base, b. When we divide b to the m power divided by b to the n, you subtract exponents when you have a common base, m minus n. Again, here is logarithm form, a single log of m divided by n. We can rewrite this dividend and divisor as into individual logs of the dividend and divisor. So this would equal log base b of m minus the log base b of n. Okay, this represents, we're subtracting what? We're subtracting exponents of a common base. Okay, this represents an exponent. The exponent b is raised to get m, right? This is an exponent, so we're subtracting the exponents, okay, from division. Okay, so if you see something like this in an expanded form, I can rewrite division. I can put it back in the single log form. Okay, when you have a power b to the m and you raise it to a power, you multiply those exponents, m times n. Okay, here I've got the exponent here of b to the m, and another way, this represents an exponent, right? The exponent that b is raised to get m. If we move this down in front, which we're allowed to do, this right here equals this. Basically, I'm doing what? I'm multiplying n times that exponent that b is raised to get m. So I'm getting the same effect here. Okay, remember we can put this down in front. So this is the same thing. I'm multiplying this exponent times this exponent. Okay. If b to the m equals b to the n, obviously m and n are equal. If log base b of m equals log base b of n, we're saying the same thing. These exponents are obviously exponents that b is raised to get m, and the exponent that b is raised to get n are obviously the same exponent because m equals n. Okay, this equals this because obviously you're raising b to the same exponent. So obviously if m equals n, if log base b of m equals log base b of n, obviously m equals n. Okay, we're raising b to the same exponent, so b squared and b squared. Obviously, m and n have to equal each other. Okay. All right. Here we go. This is I'm going to expand. I'm going to take this log, natural log of a single. This is a single logarithm, and I'm going to expand it. This would be expanded form. Okay. Remember, these are the factors of a. I've got multiplication up here and division. So remember what we can do when we have multiplication in a single log. We can expand it as and add the single logs of each of the factors. So a log of 3 plus log of x squared plus the next factor log of y, and then division is subtraction minus log of z. Okay, last step, what am I going to do with this 2? I'm going to put it down here, so I've got log of 3 plus 2 log x plus log y minus log z. Okay, all right. So this is taking a single log and put it in expanded form. Remember that a square root is the same thing if I put this x squared plus 1 in parentheses to the 1/2 power. Remember the numerator goes here underneath the radical, and the denominator goes out here. If that was a 3, you'd have a cubed root here, okay? We never put a 2, it's just a, you know, obviously assumed it's 2 if there's nothing there, all right? So now we're going to go the other way. This one's fairly complicated, okay? We're going to write as a single log. So 1/2 in the parentheses 3 log x plus log x plus 1 minus log x. So when you have addition, you can write that, you can turn that into multiplication of a single log. And I've got subtraction. I'm going to go back and write as division, okay? Work within the parentheses first. All right, notice what I do. I'm going to put this 3 back up here in the exponent form. So you got log x cubed plus log x plus 1 minus log of x. All right. I kind of put brackets around all this. Now again, here's where I take what? I've got the addition. That's multiplication. This addition of individual logs is multiplication with these. These are the factors in single log form. So I've got log of this factor, and here's the other factor, x cubed times x plus 1. And then division, the subtraction is rewritten as division, okay, of x, all right? So, and then I just take away these outside brackets and rewrite 1/2 log of this, you know, here's my single log. And again, you could just expand this out. How do we take the factors? We could go back in this format here, okay? So be able to go back and forth. Anyway, I've got the 1/2 of this single log. And what can we do with this exponent? We're going to put it up here. And we know 1/2 is actually the square root, okay? And all I have to do now is this times this. This is a factor, this is a factor. So I can cancel this x squared, or I'm sorry, x cubed over x can be written as x squared. This is, okay? All right, x to the third, and remember, subtract exponents, so it's x squared. And this is x to the first, right? So 3 minus 1 is x2. And you can write it as this, or here I just distributive property, okay? Here's one more. This one I wrote wrong. We're going to just look at this one as our last example. Let me, 1 second, I need to scroll this down. Anyway, here's expanded form. I don't know if you can see this. I'm trying to make this bigger. Okay, here we go. Okay, so here's expanded form. Let's make it to a single log. 3 log 2 plus log x. This is a common log base 10, obviously. Notice I'm going to put this 3 back up here, so I have log 2, log base, common log of 2 to the 3rd power plus log of x. Okay, so remember, this is addition of individual logs. I can take these individual logs and make these factors in a single log, okay? So 2 to the cube plus x, I can write it as a single log as multiplication of each of these factors. Each of these are the factors in a single log. So I've got log 2 cubed times x, which is basically log 8x, okay? So this can be rewritten as this and go back single log, all right, I'm sorry. This single log can be written as expanded form or vice versa, okay? That's what we're going to be doing tomorrow. That's all I have, okay? Thanks. Oh, and one last thing, be ready for some type of quiz tomorrow. We're starting off a new 6 weeks, okay? Thanks.